And we're going to apply them to finding zeros of a function. Okay? Now, I told you this semester we're going to do some really cool stuff. I love this semester. It's my favorite of the two because of some of the depth we get to go and some of what we discover with our mathematics. But it is critical that you stay on top of things. Okay? So when you're checking your homework, you're checking it for understanding. If you're not getting the homework, you're taking advantage of those help sessions that I offer Wednesday and Thursday morning. You cannot let yourself get behind. Because what we learned yesterday, you have to understand that to be able to do what we're doing today. Now, is anything we're doing this semester terribly, terribly difficult? No. But if you don't finish your homework and you haven't practiced a skill and attained it, we're going to use that skill the next day. It's not like you get 2 or 3 days to figure it out. So you can get yourself in a world of hurt quickly if you're not doing your part. And I understand that some nights it's going to be harder. Come see me. Do not wait. If you just missed one question on your homework, couldn't figure out 1 or 2, you're probably good. If you left half the worksheet undone last night, you're not okay. You should have been in here this morning. Huh? That's right. Today was Thursday. I did have 2 students come in this morning. So they should be good now. All right. So what we're going to do is we're going to start off with something very familiar. We're going to start off with a quadratic. We already know lots of things about a quadratic. You guys know how to graph this and find the zeros without me even telling you what to do. We've done these before. But let's revisit. To find the zeros of a function, how would the zeros relate to the graph anyway? Very good. The zeros of a function is where the y value is 0, which is where it crosses the x-axis. That's right. Those are your x-intercepts. So, to find the zeros of a function algebraically, though, we want to know where the function has a value of 0. So we plug 0 in for f of x. And example 1 is now just a simple quadratic that we have to solve. And we have lots of ways of solving a quadratic. But the first one we always tried was which method? Factoring. Factoring. Because factoring is the fastest if the function will factor. And this one does factor. Okay? We're multiplying to get a positive 6, which means they have to have the same signs, right? And we're adding to get a negative 5. So how does that factor?
X minus 6, X plus 1.
Got to have the same signs.
X minus 3, X minus 2.
X minus 3, X minus 2. Okay? So what could I plug in here that would make that equal 0? 3. What could I plug in here that would make that factor equal 0? 2. Okay, now when we were in the quadratic unit, we were like, ooh, that's this x-intercept form, the factored form, is a nice quick way to graph. We know we have an x-intercept here and an x-intercept here. So it's going to open up, down. Up. So it's going to look like this. We know that the vertex is halfway in between. Remember all of that? Okay. All right, you try number 2. going to just stick with quadratics. We're going to move on to cubics, and more cubics, and quartics, and so yeah. All right, so this factor 2, we know 3 is prime, and we have to multiply to get negative 8 and add to get positive 10, so a positive 4 and a negative 2 will do me, because that gives me positive 12 and negative 2. Got it. I'm starting to realize why I made you take that test over and over and over and over and over and over and over again until you made 100. Yeah. All right, so x equals what would make this 0?
2/3.
2/3. And what would make this 0?
-4.
-4. Okay, so here's our quadratic function, and we have 2 zeros. Quadratic, 2 zeros. All right, let's look at the cubic. How do we factor this cubic? It's a 4-term cubic function. Okay, we're going to group it. Very good. So that's how we're going to try this one. We're going to try grouping. First group. What does the first group have in common? An x squared, and that leaves us x plus 2. So over here we'd like to be left with x plus 2. Is there something I can factor out so that I'm left with x plus 2? -5. So this factors to x plus 2 times x squared minus 5. Well, as long as I can get it down to a quadratic, I can always use quadratic formula or one of my other methods of solving a quadratic. So as long as all my factors have a degree of 1 or 2, I'm good. And I am. I know that x can equal -2, or right here. This could equal 0. If this were 0, then the product would be 0. So if I move the 5 over, and then how do you solve this? Square root. Yes, ma'am.
I'm confused about the -5 in this the first time.
Where the -5 came from?
The one, yeah, the one.
Okay.
Though.
So I always want these two to match, right? So that I can factor out that common factor of x plus 2. So if I look at this group, what do I divide out of -5x minus 10 so that I'm left with a positive x and a positive 2? -5. Okay, so now I look at my 2 factors. This is a factor, and this is a factor. And I pull out what they have in common, which is the x plus 2. And what am I left with? X squared minus 5. X squared minus 5.
So to find the 0 with the x squared one, you just
Set it equal to
0.
0 and solve. You try.
So I'm gonna get you a button, you know, like at Staples where they have like the that would be me button. I'm gonna get you a you try button.
That'd be awesome.
What did we have how to do last year?
Do you need water?
Yeah, I need to refill.
All right, have you finished this problem? And you're confident in your solution? Okay, go.
That was
Can Anthony refill it for me?
Hey Doug, can you take my time?
I think you guys need to go in together
That's
and
one
just
boy.
buy one of those big water fountains for the room.
Oh, wow.
We could have little lines connecting to our desks. You just like press the nozzle.
Oh, no, that's ideal, isn't it?
That would get out of hand really quickly.
Would you ever like gone out there and make
Okay.
a stop?
Yeah, right at you. Blink weird.
Oh, that's what I got.
Oh, that's right.
Yeah.
Alright, so this one gives us -3, and this one gives us plus or minus √2. Okay.
I did it right.
Is there a catch?
You did it right. Awesome.
Is there a catch?
No, it just gets better. It just gets better. Y'all ready for better?
I feel like this is heading
Yes.
into a letter situation.
That's not bad.
That's not bad. Alright, go ahead and do what you can do.
I feel like it's attached to this one.
And then I'm going to watch big grins come on all your faces because you're going to get so excited at the end.
Because we got it wrong.
Thanks.
That's supposed to be green.
Is it imaginary?
Are you grinning face? Yeah.
Yeah. But what do you think?
I see why we're doing it. I see why.
Oh!
Is it because it's like I don't think I did it right then.
Why not? Yeah.
I see exactly why we're grinning.
It's just because it's
I think you do this on purpose just to make the small things bigger to us.
Oh my gosh, Miss Willoughby.
Isn't it awesome?
I don't get it. Like, what are you?
Okay, so we factor out this 16.
That's the big deal.
And even though this is a perfect square and this is a perfect square, it's a sum. So it doesn't factor any further. But when we go to solve it,
There's this imaginary number.
we get imaginary solutions.
Wait, did I get the
Oh yes.
Did you get -3? Just and then plus or minus √2?
Yes.
Plus or minus.
I did it. I just did it.
Dang it, I thought it was going to be a straight square root.
It's never a straight square root.
What made you think? What are we going to do with it now? Because I heard that we do more with it.
Well, yeah, we are.
They're great and quiet.
And so what I want you to start thinking about is, okay, this was a quadratic, think about the zeros. This was a quadratic, think about the zeros. This was a cubic, think about the zeros.
Okay.
This is a cubic, think about the zeros. This is also a cubic. Yeah.
It's going to have a...
So when we think about it, zeros.
It's one
Cubics are minus.
Okay, how many times do you think this one would cross the x-axis?
Right.
3. What about this one? 3. What about
Never.
this
Just
one?
one.
1.
Oh, just one.
Okay. Because these zeros are imaginary.
Wait, how does that look?
Like square.
How does that look? I'm so glad you asked.
I was kidding.
Oh, except I need to do it on the board because Jessica's watching this and she's going to want to know how it looks also. Okay, so cubics. They're kind of our squiggly ones. A cubic can look like this. A cubic can look like this.
Oh yeah.
A cubic can look like this.
All right.
Okay, how many real zeros would this one have? 1. This one.
3.
3. This one.
1.
1. Could we have 2? Sure we could. Ooh.
It's just so wide.
Okay? So, what we're getting to is we're going to start tying all this stuff back together. And in a couple days, we have a, beginning of next week, you guys have a lab where we're going to play on our graphing calculators. So make sure you bring your graphing calculators. And This is where you're going to connect all this stuff together, and you'll be able to graph pretty much anything. It'll be awesome. Okay, this one. It's not quadratic. It's not cubic. This one is now quartic.
I already got it.
But you know how to factor it. We did that last night.
So bad. Actually, no. I'm calling myself. This one only line of work.
Okay, did yours factor like mine?
Yes.
Okay, so when we take this first factor, and if you need to, you can set it equal to 0. If you can do this part in your head, do it in your head. Right? Okay, and then this one, and once again, if you can do this in your head, do it in your head. Okay, so how many real zeros?
1,
Two.
2.
2.
So if it has the I, they don't count.
Yeah.
Okay, they count. It makes other things happen with your graph.
That's real zeros.
These are real.
Those are not.
So, but when we talk about all of our zeros, these all are zeros, but these are our real ones.
Because those are imaginary.
So, how many x-intercepts do we have? 2. How many zeros do we have?
4.
There you go. All right. Do you want to try this one? Or?
Yes. I want to try this movie.
Okay, I'm going to let you get to a certain point, and then I'm going to kind of help you out a little bit.
You were here to try.
Get started.
Independent child.
Is that
Well, it turns into a...
Is that a
Actually, no, I don't.
Did you see Professor Burger?
Kind of done.
No.
Not as often this semester.
Okay.
Is Willoughby? Is that a
Professor
negative?
Burger was the
Where
best.
do you even start?
I know it's a f of x equals x to the 4.
How can you factor out this one?
Oh wait.
Wow, this is.
What do I do from here? Is it plus 1? Wait, minus 1.
Well, you know, this is not.
Just kidding, I didn't.
I feel like this is wrong.
No, that's it. What else would you
Okay, let's take a look.
Wait. I have to finish. I have to finish before you go on.
I thought I had it right, and then Sarah told me I was wrong, and now I'm just gonna go try to order.
Yeah.
I'm never right.
Okay, I can
I agree with this. I also agree with this.
Oh, feel.
Okay.
Oh, wait, no.
So, fortunately for you, you now know how to factor a
Cube.
sum of cubes. So let's do it. This is a sum, so the pattern of my signs are plus, minus plus.
How does it get minus? I don't get that. I get how the others are plus.
Multiply it back, you'll get it. If you distribute it back through and you see the entire process, you'll get it. What's being cubed is x. What's being cubed is 2. So we square the a, we do the product of a and b, and we square the b. So now, you probably noticed that when you factor a sum or a difference of cubes, this trinomial doesn't factor any further over the set of integers, does it? Okay? So the first two are pretty easy. We know x is either 2 or negative 2, right? But this one doesn't factor any further. So what's our next option? Quadratic formula. So we'll do negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we get 2 plus or minus the square root of 4 minus 16 is negative 12.
Oh god, that's an I.
And it is. It's not ugly.
Damn.
It's just
It's ugly.
It's just different.
Two-I.
Okay, so it's, all right, 2i root 3. So it's 2 plus or minus 2i root 3 all over 2. Does everybody see each one of these terms has a common factor of 2?
Yes.
So 2 goes into 2, 2 goes into 2, 2 goes into 2. So we're left with 1 plus or minus I root 3. So how many zeros do we have? 1, 2, 3, 4. How many are x-intercepts? 2.
Yeah.
That's enough work for today.
Yeah, I'm okay with that.
Are you serious?
Okay, I'm going to pass out your homework. Your homework is just the odds. We'll do the evens in class tomorrow. Your homework is only the odds.